Okay, so our first problem in a trigo function is, is a cosecant of 3 minus j4. So first, I convert this to 1 over sine because that is the trigo function of cosecant. So 1 over sine 3 minus j4. Next, I'll convert sine 3 minus j4 into the complex number of the sine. Next, I convert the sine into the trigo function of the z, which is 1 over, so we have sine of 3 times the hyper cosine of 4, and plus j of cosine of 3 times the hyperbolic sine of 4. Then I multiply this by the conjugate of the bottom, so it's sine 3 cos hyperbolic of 4 minus j, the cosine of 3 sine hyperbolic of 4 over the same thing. So we have sine 3, so we multiply, so it's sine 3 cosine hyperbolic of 4 minus j cosine of 3 hyperbolic sine of 4 all over. So we use the FOIL method, so we have here, and have here. So we get sine squared of 3 cos hyperbolic cos squared to 4 minus j squared times cosine squared 3 sine h squared times 4. And since your j squared is just 1, negative 1, so this will be cancelled out, so it will be plus cos squared 3 whole 2. Okay, then we use the calculator, so our final answer is 5.17 times 10 raised to negative 3 plus 0.036 j. Next one of our trigonometric functions is the secant squared times 1 plus j. So first, I convert the secant into the cosine. So 1 over cosine squared times 1 plus j. Then I use the identities for the cosine squared, which is the 1/2 of 1 plus cos of the 2 times the angle, or in this case the complex numbers. So we have 2 plus 2j. That's all over 1. Next, I just move the 1/2 to the top, so we have 2 all over 1 plus cos of 2 plus 2j. Next, I convert the cosine of this to the trigonometric functions of the z. So you have 2 all over 1 plus cos 2 of the cos hyperbolic of 2 minus j of the sine 2 times the sine hyperbolic of 2. Then we just use the calculator. We get negative 0.10 plus 0.59j. Okay, next we're gonna have the inverse trigonometric function. So our first problem is the arctan of 0.2 plus j 0.1. So to make it easier, there are two ways to solve this. So we have the long method and a short method. So now I'm just gonna use the short method because it will be very easy and it's be very quick if we are taking the exams. So we know that the arctan of z is equal to j over 2 of ln of 1 plus jz all over 1 minus jz. And since we let z here will be equal to 0.2 plus j 0.1, and there we just gonna input this to our given formula. So we have arctan of 0.2 plus j 0.1 equal to, so negative j over 2 times your ln of 1 plus j times 0.2 plus j 0.1 all over 1 minus j times 0.2 plus j 0.1. Okay, so here we distribute the j, so we get negative j over 2 ln of 1 plus, so 0.2j So j times j, that will be negative 1, so negative 0.1 all over 1 minus 0.2j. So negative j to j, that will be positive, so plus 0.1. Then we just simplify, so negative j over 2 ln. So 1 minus 0.1, that will be 0.9 plus j 0.2 all over. We have 1 plus 0.1, that will be 1.1 minus j 0.2. And this is our final answer. Sorry for this, it should be right here. But still the same answer. Okay, so this is our last problem, which is the arc sine of cosecant negative 0.3 minus j 0.4. So first, ang let A equal to the arc cosecant of your negative 0.3 minus j 0.4. Next, so I transferred arc cosecant to the other side, so that will be the cosecant of A equal to negative 0.3 minus j 0.4. Next, I convert this to 1 over sine A. So this is the simplest thing. So we have 0.3 minus j 0.4. Then I convert the sine A to the exponent for this one over e raised to ja minus e raised to negative ja all over 2j equal to negative 0.3 minus j 0.4. Next, here this is divide, so this 2j will be reversed. So it's 2j all over e raised to ja minus e raised to negative ja equal to negative 0.3 minus j 0.4. Then we multiply this to this one. So you have 2j equal to negative 0.3 minus j 0.4 times your ej raised to ja minus e raised to negative ja. So FOIL method again. So you have 2j equal to, so you have negative 0.3 e raised to ja times your positive 0.3 e raised to negative ja minus j 0.4 e raised to ja plus e raised to negative ja times your j 0.4. Then we all multiply this by your e raised to negative ja. So we get 2j e raised to negative ja equal to, so we have 0.3 eja squared. This would be 1, so 0.3. So here we have negative j 0.4 e raised to ja squared. This will be 1, so we have plus j 0.4. Next, we put all the elements of variables into one side. So we have 2j eja. So this is positive 0.3 eja squared plus 0.3. Sorry, this is negative 0.3 minus j plus j 0.4 eja squared. So minus j 0.4 equal to 0. So we further simplify this, and we have 0.3 plus j 0.4 e to ja squared plus the 2j of e of raised to ja, and we have minus. So after this, so we can use the formula to finding the roots of the quadratic equations, because we have a quadratic equation right here. So we have x, so instead of x we use e raised to ja equal to negative b plus minus square root of your b squared minus 4ac all over 2a. Okay, next we just replace all the letters from the equation that we have. So e to the ja equal to, your b is just negative 2j plus minus your square root of your b, so it's 2j squared minus your 4 times your a, which is 0.3 plus j 0.4 times your here. So your c is negative also, negative of your 0.3 plus j 0.4 all over your 2 times 0.3 plus j 0.4. Okay, so we can simplify further. So we have e raised to ja equal to your 2j plus minus square root of this. So we have 4, we have negative 4 because j squared is just negative 1. Then we have here, so we use multiply this, so we have, so let's start here. So let's take the 4 out. So you have 0.3 times negative 0.3. So I'll just move it right here on the top. Then you simplify inside of the square root. So you have e raised to j a equal to negative 2j plus minus square root of your negative 4 minus so we have minus 4 times so negative 4 times of 0.25, then we get minus this will be positive, that will be negative j 0.24 all over 0.6 plus j 0.8. So we multiply this, or we can further simplify this. So we have eja equal to 2j plus minus square root of, let's say 4, so negative 1 minus your 0.25 minus j 0.24 all over 0.6 plus j 0.8. So this will be 2 from the outside. So you have e of your ja equal to 2j plus minus 2 square root of your negative 1 minus of 0.25 minus j 0.24 all over so much, so it's all over 0.6 plus j 0.8. Then we convert everything to ln. So this will be cancelled out. This will be 1j. Okay, so we have ja equal to your ln of your 2j plus minus 2 square root of your negative 1 negative 0.225 minus j 0.24 all over 0.6 plus j 0.8. Then we divide this by 1 over j. So this leaves us your a, and your a, we all know that is the arc cosecant. So I'll just make this one go. So you have arc cosecant of your negative 0.3 minus j 0.4 equal to, so when you divide 1 over j here, it will be negative j of your ln of 2j plus minus 2 square root of negative 1 of your negative 0.25. So to find the answer, I just put it right here. Sorry for the spaces. So we have arc cosecant of your negative 0.3 minus j 0.4 equal to your ln of 2j. So I forgot here negative j because 1 over j is just negative j. So you have 2j plus minus 2 square root of your negative 1 minus 0.25 minus j 0.24 all over 0.6 plus j 0.8. So this is the final answer. Thank you so much for watching the video. Today I learned that today's topic, it's about the trigo functions and its inverse. And it's really hard. It's somehow like the same as calculus 1 and 2, but this is much more advanced because we're dealing with complex numbers. And that the video is so long, I was thinking that it will reach like around 10 minutes because it's only 4 problems, but it actually reached around 20. But I just cut down some in order to make the video to reach 10 minutes. So it's around 13 to 14 minutes of the video. And that's all, and see you in the next video.